Hi guys, this is Vineet and I welcome you to this video. Today's video topic is how you can measure the index fragmentation and page density in SQL Server. So there will be demos and practicals as well in this video. Before we proceed ahead, I would request all you guys to please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding my upcoming and future videos. The reason I'm asking you to subscribe is because I will be creating many more videos on indexes which I don't want you to miss. So that's the reason I'm asking you to subscribe so that you can get timely notifications for whatever videos I will post regarding the indexes. So please go ahead and do that right away. Subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button and follow the process. I'm waiting for 5 seconds. Please go ahead. So guys, I hope you must have subscribed by now, so we can move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept. And if it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. We would suggest you to perform any exercises in your test and lab environments only rather than touching the production environments. Please use the test and lab environments only. We would like to know your thoughts regarding our videos, so please share in your comments and suggestions. Provide us your feedback as well. We eagerly wait for your comments and suggestions, guys, so please do share your comments with us. Alright, let's move ahead. We have created some playlists for you to watch. So the reason, guys, why we create playlists are because playlists are the best way to learn about any particular area. Instead of watching the videos randomly on my channel, it's better to go through a playlist. For example, if you want to learn about indexing area, what I would recommend is go to the SQL Server indexing playlist and watch out all the videos from starting till the end to get better grasp on the indexing area. Some of our common playlists are SQL Server database design, tables, business continuity, indexes, performance tuning, integration services, and transact SQL. So far we have around 250 videos posted on our channel and the list is growing at a constant pace. My channel link page is given below, so watch that out as well. The links for all these playlist and my channel page link is also given in the video description area of this video, so please check out the video description area of this video. Now let's come back to today's topic, which is how you can measure the index fragmentation and page density in SQL Server. So let me take you to notes quickly. Today's topic is measure index fragmentation and page density. Now let's begin. There will be some theory, then we will be covering some practical. So let's start with the theory part. Now both fragmentation and page density are amongst the factors to consider when deciding whether to perform index maintenance and which maintenance method to use. So this fragmentation and page density are one of the common factors that helps us in deciding whether to perform any index maintenance, and basically helps us in deciding which maintenance method to use, whether to rebuild the index or reorganize the index. Now fragmentation is defined differently for the row store and column store indexes. So far we have not covered the column store indexes, we have only covered the row store indexes. Maybe in our next video series we will start covering out the column store indexes, so keep an eye and keep subscribed. That's the reason I'm asking you to subscribe, so that I don't want you to miss on any of the videos. So please go ahead and subscribe right away. So we were talking about fragmentation is defined differently for the row store and the column store indexes. Now for row store indexes we use the system function sys.dmdb index physical stats. The system catalog view can be used to determine the fragmentation and page density in a specific index, and it can also be used for all indexes on a table or index view, and it can be used to determine the fragmentation and page density of all the indexes in a database or all the indexes in all the databases. Now for partitioned indexes, so what are partitioned indexes? Partitioned indexes are the indexes in which a particular index is divided into many partitions. So those are called partition indexes, and the same view or system catalog view can provide information regarding each partition if we use them against the partition indexes. Now the result set returned by this particular function or view includes the following columns. So some of the important columns are average fragmentation is in the percent, and which defines the logical fragmentation out of order pages in the indexes, basically. That is also known as logical fragmentation. And second most important column is average page space used in percent, that denotes the average page density. We should give attention whenever we run this function. We should look at these columns to see how much is the fragmentation and how much is the page density. Now for compressed row groups in column store indexes, so we will cover the column store indexes separately, so I'm covering it here briefly because this topic is also associated here as well. So column store indexes contain the compressed row groups. We will cover column store indexes in detail in our upcoming videos, so keep an eye, keep subscribed. Now we are talking about the compressed row groups in column store indexes. Now in those column store indexes, fragmentation is defined as the ratio of deleted rows to the total rows. So that's how the calculation is done. Now expressed as a percentage. So fragmentation is expressed as a percentage, and it's a ratio of deleted rows to the total rows in the column store index. And there's a separate function which is sys.dmdb column store row group physical stats, which can let you determine the number of total and deleted rows per row group in a specific index, or all the indexes in a table, or all the indexes in a database. Now the result set returned by this function includes the following columns. It gives us the total rows, which basically specifies the number of rows physically stored in the row group. And for any compressed row groups, this includes the rows that are marked deleted as well. So compressed row groups are those row groups where some of the rows are deleted. That's why they are known as compressed row groups. And we have normal row groups as well. So basically total rows defines the total number of rows physically stored in the row group. And if we talk about the compressed row groups, this includes any rows that are marked as deleted as well. Now there's another column which is deleted rows, and it defines the number of rows physically stored in a compressed row group that are marked for deletion. 0 for row groups that are in the delta store. So whatever row groups are there in the delta store, this is the count will be 0. We will talk about the concept of delta store. This is associated with column store indexes, so we'll cover these concepts once we cover the column store indexes topic, which I will be releasing videos in the upcoming days for column store indexes, so keep an eye, guys. Now column store, okay, compressed row group fragmentation in a column store index can be computed using the following formula. So this formula is used 100 multiplied by this particular function. So deleted rows are divided by the number of total rows. That's what we were discussing earlier, how the fragmentation is calculated. So this is the formula for fragmentation calculation for any compressed row groups in the column store index. Now for both row store and column store indexes, it is important or especially important to review index and heap fragmentation and page density after a large number of rows has been deleted or updated. So whenever we delete a large number of rows from a table, or whenever we update a large number of rows in the table, we should always check for the fragmentation and page density, whether the table is a heap or whether a cluster index is defined on that table. For heaps that are tables without the cluster indexes, if there are frequent updates on the heaps, it may also be needed for a fragmentation review periodically. So this is true for heaps as well. We should periodically review the heap fragmentation and page density for both the heaps and the index tables or the cluster index tables. Now in this video I will only cover the demo one because we have not yet covered the column store indexes. So I will not cover how to check the fragmentation of a column store index, although I can check it here, but you won't get the idea. So let me cover the column store topic first. In this video I will only cover how you can check the fragmentation and page density of a row store index using the transact SQL. So let's trigger the SQL server. So it has given me the error message. So I need to check whether the services are running. So let me quickly go ahead and check the services, whether the default instance is running or not. So services are opened and we see the SQL Server services are not started. So let me start the default instance of SQL Server. So alright, it is started and yeah, we can now connect to it. Now we will share an example with you that will determine the average fragmentation and page density for all row store indexes in the current database. We will use the sampled mode to return actionable results quickly. And if you want more accurate result, you should use the detailed mode. And basically detailed mode requires scanning of all the index pages. Alright, so let's begin. So for this example, we will be using the AdventureWorks database, AdventureWorks 2022 to be specific. Now let me connect to it and trigger a new query against it. Now along with me you can write the code as well. So initially I do select star from. Earlier we talked about one of the views which you can query. Okay guys, let's use the view which we were discussing previously. So the view is dmdb index physical stats. So it's dmdb index physical stats is the view which we should be using. This is basically a function where we need to provide certain parameters. So first parameter is the database ID. So for that we will use the dbid function, db_id, which provides the database ID for the current database. Next option is to provide the object ID, for which we will use default option. Index ID we are using the default option. For partition number we are using the default option. And we are running this function in the sample mode, so we need to specify the sample mode. We talked about the difference between the sample mode and the detailed mode. In detailed mode, basically detailed mode requires scanning of all the index pages. Sample page does not scan all the indexes. And let's take this view as let's take the abbreviation as IPS. Let's connect this view to various tables. So let's connect it with let's do inner join with the sys.indexes, and let's take it as I as abbreviation, and let's join IPS, which is this index physical stats. We can join on the common column, which is object ID. With the i.object ID we can use, and we are joining on two columns. So second column we want to join is on the IPS.index ID. So we are joining both on the object ID and the index ID between these two tables. So i.index ID is the second column we are joining on, and we want to order it by the page count in the descending order. Now we don't want all the columns, so we will specify specific columns that we want. So first column we want is the schema name. So for that we need to use the function. So let's use the object schema name function, which gives us the name of the schema for a particular object. So the argument we need to pass is ips.object_id, object_id, and let's take this as the schema name. That's the abbreviation for the column. And we need the name of the object as well, so let's use the object name function here. And again we need to pass on the object, which is ips.object_id. I'm passing over here, so it is passed. And let's take this column as object name of the object. So first we are taking schema name, then the object name, and then we are taking as the index name, i.name as the index name. Then let's take index type. So we are taking the type description as the index type. Now let's take few more columns. Let's take it from IPS, or index physical stats. From there we can take some of the important columns like average fragmentation in percentage. We are taking that. And second column we want to take from IPS is the average page space use in percentage, which provides the page density to us. And let's take the page count as well. So page count is another parameter we can take, or column name we can take. And lastly we would like to take the allocation unit type description. Alright, let's take these some of the columns and let's execute this statement. So running this statement will provide the average fragmentation and page density for all the row store indexes in the current database, which is my AdventureWorks. For you it will be AdventureWorks 2022. You may note down this query, but yeah, this is the query in case you want to collect a snapshot for this. Let me expand this. Yeah, this is the complete query. You can take the snapshot right away and type it later on. So let's execute this query. We will get some output for the indexes in the current database. So we see following indexes are listed. So we have a total of 193 indexes. So the first column is the schema name, which is the person schema, and we have object name, which is the name of the index, I think. No, it's the object name is the name of the table. So it's person.person table, and on that we have this business entity ID index. It also provides the index type, and then it provides the fragmentation column we have, indicating how much the index is fragmented. So some of the indexes are 50% fragmented, some of them are 33% fragmented. So this column is showing the average fragmentation in percent. Next we have average page space used in percentage, which specifies the page density. So anything like 99 is good. So this defines the average page density for that particular index or object type. And then it gives us the page count column, specify the number of pages occupied by the particular object. So the first one, person.person index is consuming around 3808 page counts. One page is like 8 KB in size, so we can multiply it by 8 to get the size in bytes. And last is the allocation unit type description, which specifies whether that index stores the row type data or what type of data does it store. Another options are the LOB data, or another options we are seeing is row overflow data. So these are some of the columns which you can use to determine, especially this two, one average fragmentation in percentage and the average page space used in percent. This you can examine to verify how much the index is fragmented or the how much page density is being used. Let me also take you through another demo. So we are done with this demo, guys. We have just shown you how you can check the page density and average fragmentation for any of the row store indexes using this particular view, this DMDB index physical stats. Now let me show you how you can use the next demo is how you can check the fragmentation of a column store index using the transact SQL. So in this case we will use the method to check the fragmentation of a column store index. We'll talk about column store indexes later in our upcoming series, so keep an eye, keep subscribed if you have not done so. Please do that right away. Now we are sharing an example which will determine the average fragmentation for all the column store indexes with compressed row groups in the current database. So we will check particularly the compressed row groups in the current database and how much they are fragmented. Now you can initially do select star from, we will select from sys.indexes, and we are taking abbreviation as I for this, and let's join it with the system catalog view sys.dm db, and there's a separate view for this. So the view is column store row group physical stats. You need to take this one, and let's take that as RGS, and let's join them on I dot. First we can join them on the object ID column, so let's do that. RGS dot object ID, and second column we can join them on is the index ID. Let's make it equal to, so RGS dot index ID should be used. So this is how you join the tables, and where we are now we are specifying the condition where the RGS dot the state description, we are particularly checking the compressed index, so we want to take state description as compressed. We are checking compressed row groups. Let's take certain columns over here, so let's select those columns. So first of all we will select the object schema name, and that we can copy from the previous query as well. Let's take this, there will be little bit of modification, so let's take this and instead of ips dot object id we will use I dot object id, and similarly we can remove ips here as well. So I dot object id we are taking it as object name. Next column is we can take I name as index name and I type description as index type. So let's take these two columns as well. So we have taken them here, and now let's use the formula to calculate. Earlier we were discussing about the formula here. This is the formula to calculate the compressed row group fragmentation in a column store index, where we find the percentage using the deleted rows divided by the total number of rows. So let's use this formula. So we can write this as well. So let me show you how you can write this. So you need to multiply 100 with we need to use the function is null. So if the let's do a sum on the rgs dot deleted rows, deleted underscore rows. So we are taking a sum of this, and if that sum comes out to be null, then 0 is returned. So that's the reason we are using the isNull function over here. First function is isNull, and let's close the bracket as well to complete the isNull function, and let's divide this information by the same function. This is the nullif function, and let's again take some function and take rgs total rows. We are taking the sum of total rows, and basically these functions are same as null and nullif. We can use both of them, and basically this will return zeros if the sum comes out to be a null value. Here also, if the sum of rgs to total rows comes out to be a null value, then the function will return 0. Alright, and let's take this column as the average fragmentation in percentage. So we can specify it as average fragmentation in percent. Alright, so we are done, and we can group this information as well. We need to group the information, so let's group it by object id, I dot object id, which is the first column. Second is we can group by index id, which is the second column over the top. So first is the object id, first is the I dot object id we are grouping it on, then we are grouping it by I dot index id, then we are grouping it on the index name, which is I dot name, and then we are grouping it on by the type description. So these are the first 4 columns we are grouping them on, and let's order it by the schema name and then by object name. Then we can order it by the index name, then order it by the index type. Alright, so this is the code which you need to execute to find the average fragmentation in a column store index with the compressed row groups. So this is the formula which is used to calculate that information, the average fragmentation percent, where we take a sum of all the deleted rows in a compressed row group, and we will divide it by the total number of rows, and we will take a sum of deleted rows and divided by the total number of rows, which provides us the average fragmented percentages of the compressed row group. Now let's execute this statement to find out the information. So there is an incorrect syntax, so we have to use 2 commas here. So let's remove one of them and execute this statement. So right now we don't see anything, so maybe there are no row store indexes present in this database, so that's the reason we haven't got any information. So let's leave it for now, otherwise we do get the information. Yeah, the code is correct, and you can take a snapshot of this code if you want to write this later, if you have not written that along with me. So guys, we are done with demo 2 as well for this video, and we are done with this video as well. So in today's video we have discussed about how you can measure the index fragmentation and page density for the row store indexes and the column store indexes, and we have discussed about how you can use the sysdmdb index physical stats function, and for compressed row groups or column store indexes you can use the sys.dmdb column store row group physical stats function to find out the fragmentation and the page density level. So guys, I hope you like the content of this video. If you really like the content of this video, please click on the like button below this video. And guys, if you are new to this channel and if you haven't yet subscribed to the channel, please go ahead and do so. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. I'm giving you 5 seconds right away, so please do that right away. There's a subscribe button below this video. Click on that button and follow the process. Alright guys, I hope you must have subscribed by now. If you have subscribed, please comment on this video that you have subscribed. Guys, do post in your comments and suggestions as well. Also provide in your feedback as well. We eagerly wait for your comments and suggestions and would love to read the same. And also guys, if you have a good network of friends who also work in SQL Server domain, please ask them to join my channel, and you can also share my videos with them using the share button below each and every video, where you can using that you can share my videos with them over any of the social media platforms. So I hope you will share my videos with them and will ask them to join my channel. I thank you so much for your time on this video today, and you have a wonderful day ahead guys. Thank you.